The spiral pattern is the next of our patterns that we are looking at, and this one again is something that you'll tend to see very often because humans have a very strong affinity to spirals as well. If you look at in the course notes, there's actually a video I call Doodling in Math Class that we'll get into that talks about spirals in nature, patterns in nature, and also the golden spiral and the Fibonacci ratio, which is very much present in nature as a result of nature's evolution. So when we look at spirals, spiral is specifically conveying an information that is a function of something speeding up or slowing down, or concentrating or dispersing of a material. So if we look here at the nautilus shell or the snail shell that we're looking at, the snail itself, when it's small, has a body, a soft body inside a shell with an opening, and that opening is where the foot is, it's where they eat, it's where they poop. Actually, they poop out the top, but they then need to get bigger, and they, instead of leaving the shell and finding a bigger one like a hermit crab, they actually will grow their shell and they'll add on in a spiral form. So it goes slowly around the shell and gets bigger and bigger and bigger, and that's the way that this creature can disperse its shell to increase its size over time. So there is a result of the form of how it grows. So the spiral in and of itself is specifically explaining to us something that is speeding up or slowing down, or concentrating or dispersing. The next example that we're looking at is an experiment that demonstrates the Ekman spiral, which is the disturbance pattern of a flow of fluorescent liquid that is going through a stream of flowing water in a lab. And you can see on the left here, there's an image that is a circle, that is a pencil that's been put into the flow to disturb it, right? Disrupt it. So it has to go either to the top or the bottom of that pencil, which is actually left or right when you're looking at it in the lab. For this is the top view. And so it goes to the top side, it goes around one side, and that collapsing that pattern as it goes around, you're basically increasing the speed of flow as it has to go around this item, and that speed then collapses behind the pencil, causing a disturbance pattern. So that causes the flow to collapse in one direction and back, and each time it collapses, it disrupts the flow and causes that spiral again and again. So the spirals we're looking at are a result of that disturbance to the medium that that is flowing around the pencil, basically. When you're driving on a highway, you can feel this. I don't recommend feeling it, but if you get too close to a transfer truck, you will feel the spiral as it is going around your vehicle and then coming back towards the truck. It will actually push you towards the truck. Some people try and use this for fuel savings, but it's incredibly dangerous because when that truck stops abruptly, you're too close to stop properly, and the wind is actually going to accelerate your vehicle into that transfer truck. So definitely not a good spot to be, but it is something that is around us everywhere, these Ekman spirals. You can see here in this image, these are clouds that are moving, very thin sheet of clouds that's just touching the top of a mountain. And as they're flowing over the mountain, that causes a disruption pattern that shows us the Ekman spiral. The next example that we're looking at here is actually a combination of two patterns. As we begin to understand pattern, we really will start to see there isn't any exclusivity. You don't just see a spiral or a branch or a lobe. You'll start to see versions of them combined and connected together. So here we're looking at the spiral orientation of the leaves of this actual agave. So this agave, the leaves are basically, there are growth points along the stem of this plant. It'll grow new leaves, and then those growth points will shift a tiny bit so that the next iteration of leaves will be offset. And this is to maximize the solar orientation. If the leaves were parallel lined up, they would block each other out. So when they're staggered, they're actually gaining more solar real estate, basically. So the orientation of the leaves is through a spiral pattern in order to increase the ability of these leaves to capture and collect more sun. The leaves themselves are lobes, which are there to exchange sun, nutrients, gases, and moisture with the atmosphere. And so the lobes are oriented in a spiral pattern in this specific design because they both have different function.